Last time we discussed about the cross product, how to carry out the cross product and how to find the product by taking the determinant. Okay, I, J, K and everything I have explained that you should write I, J, K. Then if first vector is A, then X component, its Y component and Z component. If second vector is B, then it's X component, Y component and Z component you have to take, and then you have to simplify by taking, say, first of all I, and then close this row and this column and multiply these two, that is AY BZ minus AZ, then you have to multiply these two AZ BY and so on, say minus J cap you have to take, and then we have to close these two. Okay, then AX BZ minus BX AY and plus K cap you have to take. Okay, then you close this and this, then you will have AX BY minus AY BX. This way you can find. Okay, today we shall discuss its application in the field of physics, and first we shall explain the definition of angular position, angular displacement, angular speed, everything that of a rigid body we shall explain. Now it's very easy to understand. Try to consider the motion of the top you must have played in your childhood. Okay, now see, any particle that of the top you consider, say it is here, say at P point, or this is the particle at any time, say T. Okay, now if it is moving in this direction, then after some time this will reach at P prime, here it will reach. Okay, now it's very logical and very easy to understand. Okay, so at T it is having its position vector as, say, R, or we can say radius of this particle P is R. Okay, and it is at point P. After some time it will go on the circular path. Okay, and it will subtend some angle here, that is delta theta. So at time T plus delta T, it is at P prime by subtending the angle delta theta. Okay, now it is having delta theta angle, or we can say it is subtending delta theta angle in time interval of delta t. So this rate of subtending angle, that is delta theta upon delta t, is defined as angular speed. Try to understand. Rate of subtending angle is known as angular speed. That's all. Okay, now try to understand it this way, that this is, first of all, we got the understanding of this angular speed. Okay, now if you consider any reference line, okay, then the position of the particle of the rigid body with respect to any reference line, or we can say angle subtended by the line joining the particle to the reference point, line joining the particle with reference point. Try to understand this way. I am trying it in a different way. Okay, say for example, you have this particular axis, that is x axis and y axis, and if you have, this is a rigid body. Okay, say you have this particle P here. Okay, then if you consider this as a reference point, okay, then the line joining the reference point is subtending some angle. Line joining the reference point to a particle is subtending some angle with the reference axis. Say this is your x axis, then this angle which is subtended will give you the angular position of particle. Say for example, this angle is 60 degree, then we can say particle is at 60 degree with x axis. Okay, then change in angular position, say after some time it goes this way and some angle is subtended, okay, when it is say rotating. Okay, so after some time it goes this side. Okay, so after some time say 10-degree angle it has subtended, so we can say that there is a change in its angular position, which is known as angular displacement. Okay, so angular position is the angle subtended by line joining the particle of the rigid body with the reference point with some reference line, angle subtended by line joining the reference point to the reference particle. Okay, reference point here, and this is our reference particle. The line joining them is this. Whatever angle is subtended by that line joining with the reference point to the reference particle with some reference axis, that is the x-axis, say, then that angle is giving you the angular position, and change in the angular position will give you angular displacement. And the rate of change of angular position at what rate, that is delta theta upon delta t, that will give you the angular speed. Okay, this is the crux of this whole discussion. Okay, so here some angle is shown, okay, which is subtended by this particle, and it is given here as the angle subtended delta theta is nothing but, try to understand, just I am zooming it. Okay, the angle subtended is P prime C P, which is nothing but delta theta in how much time, in time interval delta t. Say at any time t, the particle which is under consideration is here. After some time, say t plus delta t, it comes here. So in time interval of delta t, it subtends angle delta theta. So rate of subtending angle, that is delta theta upon delta t, is defined as angular speed. Okay, so this is average angular speed, which is given by delta theta upon delta t. If delta t is taken very small, then it will give you the instantaneous angular speed, or rather if you consider its direction also, then it becomes angular velocity. By taking delta t tends to 0, then it becomes delta theta upon delta t, that is d theta by dt. Okay, so here angular position is defined as, okay, the angle made by the line joining the particle with the center of its circular path at a given time with a given fixed reference line is called the angular position of the particle at that time. It is denoted by theta. Angular displacement is nothing but change in the angular position, is known as angular displacement, and angular velocity is time rate of change of angular position of a rigid body, nothing but it is angular velocity. Okay, now direction of angular velocity is found with the help of right hand screw rule. Now see, try to understand, this is a particular, say for example you consider this as a disc, okay, and it is rotated in this way. Okay, so it is rotated this way. Now if you rotate it this way, then the right hand screw, try to understand, right hand screw will go in which particular direction. If you have a right hand screw, you also rotate the right hand screw also in the same direction. Then if you rotate it like this, in this particular direction, okay, then it will advance in the upper direction. Okay, so if you are rotating it this way, then it will advance in the upper direction, so the direction of angular velocity will be in the upper direction. Simple, you can understand from this figure. If you rotate this disc in this particular direction, that is say clockwise, then in which direction the screw will go? Screw will go inside, so that is the direction of angular velocity. And if you consider the anti-clockwise rotation, Okay, this way if you rotate like this, okay, then in which direction the screw will advance? Screw will advance in this particular direction, or we can say coming out of the plane, or this way it will come. So direction of angular velocity will be coming out of the plane in this direction for anti-clockwise rotation, and for clockwise rotation it will be going inside. Very easy to understand. Okay, so by using right hand screw rule we can understand the direction of angular velocity. Now see, this figure is also having its own significance. Say for example, this is the particle P. Now it is rotated in this direction, so instantaneous velocity will be in this direction. Let me try to explain it this way. Okay, now see, this is the particle under consideration. It is rotated in this direction, so instantaneous velocity will be in this particular direction. Okay, now its radius is in this particular direction. Okay, now if you are rotating it in this direction, then the right hand screw will advance in the upper direction, and that is why the direction of angular velocity is taken in the upward direction. Okay, now it has been explained in a different way in the next topic. Okay, this is considered to be the reference point, and with respect to reference point, say for example, this is the position vector of particle P, which is r. Okay, and this vector r, try to understand OP, that is vector OP is a resultant of OC plus CP, vector addition of OC and CP. Okay, that is explained in the next topic. By considering it, how can we show the angular velocity, linear velocity, and this radius, or a relation between radius, angular velocity and linear velocity is explained. Okay, now first of all we shall discuss about the scalar relation. Try to understand scalar relation between the omega and r. Okay, now first of all, omega r and linear velocity. Okay, so first of all try to understand the scalar relation, then we can go for the vector relation. This is the particle P, which is somewhere here at some time, say t. After some time it comes here, so the angle subtended by it will be delta theta. This angle will be delta theta, and the radius is going to remain same, so this is its radius r. Okay, now as you know that omega is nothing but delta theta upon delta t, that is time rate of change of angular position. This is the position of particle at some time t plus delta t. Okay, so it is somewhere here. Now it is traveling delta theta angular displacement, it is performing angular displacement of delta theta and delta t times omega is given by this particular formula, that is delta theta upon delta t. Now see, its linear displacement means this displacement on circular arc, that is arc P prime, okay, can be arc is equal to radius multiplied by theta. So its linear speed is nothing but linear displacement, that is arc P prime upon delta t, that is time interval. So this can be r delta theta upon delta t, and delta theta upon delta t is omega. So V is equal to r omega, and this is the scalar relationship between linear velocity, angular velocity, and the radius of the particle performing the rotational motion, or we can say particle under consideration. This you must understand, that V is equal to r omega. Now just by logic, try to understand, just by logic we can get the vector relationship. Try to understand how to find vector relationship. Now this V is equal to R omega is our scalar relationship. V is equal to R omega. Now see, R is a position vector, omega is angular velocity, and V is velocity. All the three are vector quantities. And two vectors are multiplied, that is omega and R are multiplied in such a way that finally you are getting vector quantity. So it must be a vector product. Now it is R cross omega or omega cross R, that we shall have to decide. Okay, either R cross omega or omega cross R is correct. Now try to understand the figure. Okay, now see, when the particle is moving from this position to this position, okay, by traveling say angular displacement delta theta, try to understand, whenever it is here at point P, its linear velocity is in this direction, and that direction is tangential direction, tangential to that particular point. Okay, now always when you are moving in this particular direction on this circular path, okay, this circular path, when you are moving, then your right hand screw is going to move in upward direction. So omega has fixed direction, that is in the upward direction. Now we have R. R is in this direction. Try to understand. Now we have the formula V is equal to R omega. Now we have to decide whether it is R omega, R cross omega or omega cross R. Now if this R is rotated, if this vector R, try to understand, this vector R is rotated in the direction of omega, then right hand screw will come out of the screen, and that will not give the direction of velocity. Direction of velocity is in this particular direction, and the right hand screw is moving in this direction. So R cross omega is not possible. If you rotate this vector R in the direction of omega, then the right hand screw comes out, and that is not giving you the direction of this linear velocity. So R cross omega is not possible. Then only one possibility, omega cross R. Okay, again I am showing it by the drawing. Omega cross R we have to do. This is vector R. Now this is omega, rotate omega in the direction of R. So if you rotate omega in the direction of R, then the right hand screw will go inside, or it will be in the direction of velocity. So we can say that V is equal to omega cross R. This is the simplest way you can understand the vector relationship between V and omega and the position vector R. The mathematical explanation is given here. See, first it is taken to be omega cross R. Now R is nothing but, I have explained you last time or in the last topic, that it is nothing but OP is R. So what will you write? OC plus CP. So OC plus CP is written instead of R. OC plus CP. Now just open the bracket, omega cross OC and omega cross CP. Now omega cross OC. Now omega and OC both are in same direction. See, OC is in this direction, omega is in this direction, angle between them is 0. So we can say omega cross OC, that is omega OC sine 90. Omega OC sine 90 will be, sine 0, because they are in same direction, so angle will be 0. So sine 0, so it becomes 0. So this part, omega cross OC vanishes. So only one part remains, omega cross CP. Okay, this omega cross CP only will remain, and a CP is nothing but R, you can see in the figure. Okay, CP is R, that is radius, which is denoted here by R perpendicular. Okay, So instead of that Cp, we can write omega r perpendicular. So omega r perpendicular sine 90, because r and omega, they are in the mutually perpendicular direction. See that I have explained, r and omega are mutually perpendicular, so angle between them is 90 and sine 90 is 1. Okay, so it becomes omega OC omega Cp sine 90, and sine 90 is 1 and Cp is nothing but r perpendicular. So omega r perpendicular sine 90, or we can say it is omega r perpendicular, which is nothing but the radius of the circular path. But omega r perpendicular is equal to the magnitude of linear velocity at point P, and therefore V is equal to omega cross r. Rather, it has been explained in such a way by taking some mathematics, but finally you are showing the logic only, that omega r perpendicular is equal to the magnitude of linear velocity at point P. After all, we have to go for the figure. See, here omega and r, they are perpendicular to each other. Okay, omega and r are perpendicular, and if you find the omega cross r perpendicular, then it will be in the direction of velocity. So we have to go for the figure and the use of vector product. So we can write the linear velocity, rather relationship between linear velocity, angular velocity and r as v is equal to omega cross r. As such, it is used using the right hand screw rule to determine this direction. Okay, the direction of omega does not change with time for a rotating body about a fixed time, but its magnitude change with time. Okay, it if the axis is not remain fixed, direction of angular velocity changes with time. Okay, axis we are considering right now fixed only. Hence, in general, for a rotating body, the magnitude and direction of omega changes with time. Okay, that depends upon in which situation the rotational motion occurs. Okay, now change in angular velocity is nothing but the angular acceleration, as change in linear velocity is giving you linear acceleration, or we can say acceleration in general we have studied. Okay, similarly here also the time rate of change of angular velocity is nothing but angular acceleration, which is denoted by alpha. Okay, so we can say that it is having its unit radian per second square, as omega is having the unit delta theta upon delta t. Theta is measured in radian and time is measured in seconds, so it is having unit radian per second. Here it will be radian per second square. Okay, so we can say alpha is delta omega upon delta t, that is average angular acceleration, that is change in angular velocity delta omega upon delta t. And if limit delta t tends to 0, if it is taken, then it becomes instantaneous angular acceleration. Limit delta t tends to 0, delta omega upon delta t is termed as d omega by dt. Or we can say, if you write omega as d theta by dt, then we can say double derivative of angular displacement alpha is equal to double derivative of angular displacement, that is d2 theta by dt2. Okay, so up to this you try to understand properly. Okay, and we have completed up to 7.6, that is angular acceleration, and then next time we shall talk about topic number 7.7, that is torque and angular momentum. Okay, thank you very much.